Hello and welcome to the next session. Now in this session I am going to talk about how to manage different environment and how to maintain the product code. Now as we know that data science projects are very important and they have a lot of open source library, and one of them is a Python open source library. So data science project depend on a lot on open source library and tools for doing the data analysis. Many of tools are constantly updated with so many number of features added every day, and sometimes even the API are also important. So you can see that I have written Python environment. It is available on the Python http github.com Python environment as a tool for managing the Python distribution on a single machine. Different project may use different Python versions, and PYENV, that is Python environment, allows you to switch between different Python version between the projects. So very useful. Second is virtual environment. So it's a tool for creating virtual environment that contain different type of Python packages. Virtual environment are useful for switching context between different projects that may require the conflicting version of the Python. So you are using 2.3 version or 3.0 version or 3.1 version. You can use these libraries for a ecosystem. Okay, then we have Anaconda. So Anaconda is a very well known distribution library available, and we can use Anaconda for sharing a lot of things. Okay, so we already, I hope all of us know about the Anaconda. Okay, so Anaconda is very important, and considering the we can use the conda or pip command to install the software or to install the library, anything we want to have, even TensorFlow, everything we can install on the Anaconda. So you can see that pip and conda, these are the two very important command prompt for installing the software on Anaconda. Either you can use a command prompt pip or a conda, and you can see that the conda has been increasing for a very long time, and TensorFlow training performance is very good on the Anaconda. Now a very important consideration about the project is tracking the experiment, which version I am talking about. So experiment lies at the core of my DS, and data scientists perform many experiments to find the best approach to solving a particular task in hand. In general, experiments exist in the set that are tied to a data processing milestone. For example, feature generating or feature engineering experiment, experiment with different machine learning algorithm, hyperparameter optimization experiment. Now, if you concentrate on these 3 points, okay, so feature engineering is very basic and very important for generating any kind of data science project. Then I have different machine learning algorithms. So which algorithm will be giving me a best result, which is another tracking the experiment. And the final and very important point about the optimization is hyperparameter tuning. So these three gives me a very good idea about the experimental setup and tracking. Okay, and we can have a set of making a track library. So we can use a metric tracking file as follows. So if I am doing a CSV file, comma separated file or a comma separated version file, then I can use a Excel sheet or any other sheet to have a minimum set of column for a tracking called as metric tracking file. So you can write experiment date, code version, model name, model parameter, training data set link, validation data size for cross validation, test data set, test data link, metric result, that is 1 column per metric or 1 column per data set, output file, and experimental description. So this kind of metric tracking will give me my project a very good leverage. Okay, so these are all the bookkeeping I can do for my project too. So the data science community uses these 3 major open source licenses that allow a tracking of all the experimental detail, and these tools track much of the functionality than experimental tracking. Now Secret, this is the advanced experiment tracking server which modular architecture. It has a Python framework for managing and tracking the experiment that can easily be integrated into a existing code. Secret also has several UIs that allow our team to have a browsing experimental result also. Out of the other solutions, Secret focuses fully on experimental tracking. So whenever I am doing a experiment or enhancing a version, so I have to keep track. So I have a very good, beautiful software available called Secret. It captures the widest set of information, including server information, metric, artifact, log, and even experimental source code. So with this, we can have a very good result available. Second is machine flow, ML flow. Okay, this is the experimentation framework that allows tracking experiments, serving model, and managing data science projects. So ML flow. ML flow is easy to integrate and can be used both in the client server architecture or set up locally. Its tracking feature lag a bit behind the Secret powerhouse, but will be sufficient for most data science projects. So I can use a ML flow. ML flow is also providing tools for Jumpstart project, from a template serving training to the model API and quick way to publish the experiment as a what we call a product ready service. The third is DVC. This is a toolkit, okay, available version control. So this is a toolkit for data versioning and pipeline management. It also uses a basic file feed system for tracking all the functionality. So whatever ML flow and Secret offer, this can also be offered by DVC as a development tool. Okay, then we have a very important concept called as automating of a data tools, or what we call as importance of a automated testing. Most of the software which are being developed, they undergo through a rigorous testing process. So when they go under a rigorous testing process, we go for a automated testing, okay, as is a mandatory in software engineering project. Slight changes in the code can introduce uninterrupted bug in the other part of my code. So this is a bigger problem. So a small code change can have a introduction of a bigger code problem in other part of the solution. So it is important to check everything works as intended and as frequently as possible. Automated tests that are written in a programming language allow testing the system as many times as we like. So these are called as CI advices, running the test each time a code is pushed to a new version control. So whenever a new version is being introduced, like a Python new version is introduced, I have to have a automated test. So this kind of system or this kind of environment for a development will be very useful. So in software engineering, we can divide all the tests into a hierarchy. Number 1, end to end. Number 2, integration test, and number 3 is unit test. I hope every one of us are familiar with the software testing methodology. So we can do a hierarchy and we can test end to end test set, integration test set, combining all the pen together, and finally a unit test. So in the world of software testing is so technological development, can a data science project be benefited from a automated testing? Answer is yes. Only the main difference between data science code and software testing code is the reliability of my data, because in my data science the data is keep on changing, not static but dynamic. A fixed set of data set can be generated before a test run is sufficient for most of the software project. However, in DS project, the situation is different. For a complete test of the model training pipeline, you may need a gigabyte of the data. So data is a big problem. So your software testing methodology will not be sufficient for DS project. So you have to do more. So for this reason, many data science projects avoid automated testing. You have to go for, okay, so they suffer from a unexpected bug, ripple effect, and slow changing integration. A very good term here in data science is called as ripple effect. What is ripple effect? A ripple effect is a common software engineering problem when a slight change in one part of the system or a code can affect a larger or a unexpected way into another part of the system, causing bugs. So automated tests are an efficient solution for detecting ripple effect before they can cause a real damage. So despite of this difficulty, the benefit of automated testing are too great to ignore. So ignoring tests turn out to be much more easier and costlier than building them. So we can go for a automated testing also about the tools. Okay, so we have so many tools available on automated testing also. So the benefit from automated testing from our project will be architect your code for a better testability. So whenever a test code is being written, it updated, it will be better going for a testability. Start small, write unit test, consider building integration and end-to-end test. Keep it Okay, remember that testing saves time, especially those nights when your team has to fix unexpected bugs freshly deployed by the code. So these are what we call a very important point for my software development and software testing, especially in data science. A very important another feature of the data science project is packaging the code. So packaging the code is writing a script. You can write a script using Python or PyTorch or any other, and you can write the package using the setup py file as a much more convenient way for a Python code to package. So you can package the entire code using the py library, or you can using your own set of the code. Another very important and very popular nowadays is a virtual environment called as Docker. So you have Docker image. So Docker is available on the docker.com. It's based on the technology called as Linux container. Very powerful. Docker allows packaging your code into an isolated portable environment that can be easily deployed and shared on any Linux compatible operating system. It's like packaging, shipping and running your application along with all dependencies, including Python interpreter, data file and operating system distribution. So a Docker image form from a set of commands specified as a Docker file. A running instance of a Docker image is called as a Docker container, as very popular, and nowadays most of the software development is through the Docker. Continuous model testing, perform static. Okay, so describe the continuous model testing. We have CI, that is continuous improvement, perform static code analysis and launch a automated test. We have already seen CI CD. Okay, so CI is for your performance static code analysis, launch automated test, and the next one is continuous model testing. Fetch the data, generate a EDA report, launch new data quality, train a new model, test the performance quality and fix the experimental setup. CD is your deployment. Okay, package the new version, package all the source code, publish the set target on the server and launch the new code. So with your CI/CD server, we can solve all this pipeline problem on the project very easily. And this is a case study. I hope everybody can read the case study. It's a case study showing you how a model OPS for a predictive maintenance system can be employed. Okay, so Oliver is a team member of a data science project for a large manufacturing company called as Manco, whose plant can be found in multiple cities around the country. Oliver team developed a predictive model called as a model that can help the Manco company to forecast and prevent expensive equipment breakages, which result in costly repairs and long production line changes outages. The model takes measurement of multiple sensors input and output a package probability that can be used to plan a diagnostic and repair session. So you can see that each piece of this equipment is unique in its own way because it operates under different conditions on each of the Menco plant. So what is the pipeline? There are several data scientists on the team, so that they needed to share a tool for sharing the code with each other. The customer requested for security purposes all code be shared on the local machine. So you can use your JIT hub, you can use in terms of the code, and these things are very easy to incorporate on a data science project. So using all this phenomenon, we can use a JIT hub, or we can use a Docker image, and we can use all these features to have a test code written. And you can see that project looks like this. And when you employ the project, okay, we have all the Linux library, authors, changes, license, readme, config.data, external interim process raw data. This thing already we have seen in the earlier sessions. Okay, so external interim process raw data, environment model, then notebook, all these things we have seen earlier. So these are all the taken from the library function. So we can use a setup project, and we can define the configuration file, we can define the py file, we can define the source file, we can divide the coverage, and every commit configuration we can define on the data science project. So this looks like if you take a screenshot, and this is from the author's book, the screenshot looks like this. It is showing you how much time it is being artifact location, what is the test example, search result, okay, file sharing parameter, all these things are available here, and it will show you how much parameters have been tested, what is the metric performance, each and everything become automated. So with this kind of automation, it is very useful for a data science project. Okay, so you can see these are all the binary code, these are all the executable code written in the Linux operating system on a bash. Okay, so you can go through all the descriptions if you want. Okay, so the overall model process of the project contain the following step: create a new change in the code, run the pre-commit test for a quality control, run the PyTest on the JIT hub or on the using CI/CD, package the code container with the Docker image, okay, and push the Docker image on the Docker registry on the JIT hub. After manual configuration, we can use a Docker image and we can configure it. So this is the what we call as a creating an end-to-end model OPM pipeline streamline through the deployment process. So with this, I end the chapter. Thank you.